Hey, ladies and gentlemen, today we're going to go through our waves notes. So, what is a wave? A wave is a disturbance that travels through a medium. This disturbance will cause the particles of that medium to oscillate side to side and return to their state of equilibrium. Now, a medium, or what the wave travels through, is just the substance that that wave is traveling through. It can be air in the form of, or sound waves travel through air and liquids and stuff like that. It's just whatever that object is traveling through, or that wave is traveling through. Now, the parts of a wave. We have a crest. This is the peak of a wave. A trough is the bottom of that wave right there. The amplitude is going to be the distance between the midline to a crest or the midline to a trough. And a wavelength can be measured as one full wave. So trough to trough is what we're seeing here, but it can also be crest to crest or one full wave like this. Now, like I was saying, there are three different ways you can measure that wavelength: crest to crest, a full wave, or trough to trough. Now, wave behaviors. Waves are going to behave in different ways when they interact with other or with different objects. Absorption. Now, this occurs when a wave encounters matter, and that matter will take the energy from the wave and transmit that energy into its particles. This commonly happens with darker colors in sunlight. Darker colors will absorb that sunlight and cause you to heat up if you're wearing darker clothes out in the sun. Diffraction. This occurs when a wave encounters an object in its path. The wave will bend around that object and fill the space. So we can see that this wave is encountering a tiny slit and it's going to diffract from that slit and fill the space over on the opposite side. Then we have reflection. This occurs when a wave encounters a solid object and instead of being absorbed by the object, the wave bounces off of it. This is commonly seen with mirrors or lighter colors like white with sunlight. Instead of absorbing that energy, it will reflect that energy. Refraction. Excuse me. This is the bending of a wave due to the change in the medium that that wave is traveling through. So you can see this pretty commonly with straws in a glass of water where it doesn't look like the straw is lined up with where it is in the water. Now, my favorite example of this is that if you are ever trapped on a deserted island for whatever reason and you need to go spearfishing for food, aim below where the fish appears to be in the water. This is because you are viewing the refracted position of that fish where it's not actually located. So you need to aim below the fish or the apparent position of that fish versus the real position. So aim below the fish to actually hit the fish. And then we have interference. Now, there are two different types of interference that we'll be talking about here. There's constructive and destructive interference. Constructive interference is when two waves meet in a way that their crests or troughs will line up. This is called constructive interference. This will give us a wave with a much higher resulting amplitude. So the amplitudes of the two waves will be added together. So here we can see wave A and wave B. They're coming at, or they're moving towards each other. When they're right on top of each other, their amplitudes will add together. And then afterwards, they'll pass on their way just as they were traveling before. This is something you can demonstrate with a jump rope. Have you and a friend on either end. Each of you oscillate the jump rope at the same time, and you'll be able to view this, where you get one giant bump on the jump rope before it continues moving on. Now, the other type of interference is destructive interference. Destructive interference is when we have a crest and a trough lining up, rather than a crest and a crest and a trough and a trough, like we have with constructive. Destructive interference is going to be the opposite, where we have a crest and a trough that meet and cancel each other out, or result in a much, much lower amplitude because of the subtraction of their amplitudes. All right, ladies and gentlemen, that concludes our wave notes here today. I hope you guys have a good one.